Hey guys, today we're going to continue our work with three-dimensional shapes and we're going to talk about pyramids. Now, pyramids are three-dimensional shapes that have a triangular face or triangular faces. And we've seen pyramids before when we studied ancient Egypt or when we studied Mayan civilization. But unfortunately, I wasn't able to bring either of those monuments here to show you because they were kind of rooted to where they were. So what I do have are some plastic models, okay? So here is one of the pyramids, okay? And here's another. And those are different because of their base, which we're going to talk about right now when we talk about what they would look like if we were to open them up. Okay, they're nets. And you can see that there we have two different pyramids. We have a rectangular pyramid which has a rectangular base and 4 triangular faces. And we have a triangular pyramid which has 4 triangles. Okay? It is composed of 4 triangles. So if we look here at the one triangular, or rectangular, pyramid, we can open this up and it's got 1, 2, 3, 4 triangles and a rectangular base. And then the other type of pyramid, okay, if we open this up, okay, it's got the triangular base and then the other 3 are triangular faces. So when we talk about surface area, again, remember that surface area is the sum of the area of the faces and the base. Okay, we're trying to find what the area of each of the faces are and add that together to get the total surface area. We're going to, for a rectangular based pyramid, add up the area of the triangular faces, all 4 of them, and the rectangular base. And then for the triangular pyramid, we're going to find the area of the triangular faces, okay, all 4 of them, and add them up, and that will give us our surface area. Now, there's a new concept when we're dealing with surface area and pyramids that we have to talk about, and that is called slant height. Slant height is the measure of the height of the triangular face, okay? And that is not to be confused with the height of the actual pyramid itself. So the slant height comes down from the apex of the pyramid, okay, the vertex of the pyramid, all the way straight down, perpendicular to one of the base sides, okay? And you can see it's a dotted line, so it's not actually a solid line on the pyramid. Okay, it comes down and forms a right angle. And we often see this given as a script of L for slant height, or sometimes you'll see it as an S for slant height. And again, I do want to stress that the slant height is not the height of the pyramid. It's the height of the triangular face on the pyramid. All right, so let's look at some examples. So on this example, I've got a square base of 6 by 6 meters, okay? 6 by 6. And I've got a slant height of 5 meters. So we figure out the area of the base, which is 6 times 6, which is 36 meters squared. And then we figure out the area of one of the triangular faces, so 6 times the 5, which is the slant height. Divide that by 2, leaves me with 15 meters squared. And then 6 by times 5, divide that by 2, leaves me with another 15 meters squared measure. And then again, we come down here, over here rather, 6 times 5, the height, divide that by 2, leaves me with 15 meters squared. And then we do it for the last triangular face, 6 times 5, divide that by 2, leaves us with 15 meters squared. And then we would take 15 and 15 and 15 and 15 and 36 add those together, and get 96 meters squared for the surface area. Sometimes our bases that are rectangles are not perfect squares. Sometimes they're actually rectangles. So in this case, I've got one base length of 8 and then a width of 6 with a slant height on either side of 11. So we find the area of the base, which is a 6 by 8 rectangle, which will leave us with 48 feet squared. And then we find the area of one of the triangles, triangular faces. So base of 6 times the slant height of 11. 6 times 11 is 66. Divide that by 2. We get 33 feet squared. Now this face has a partner, which is in back of the triangular prism, or excuse me, pyramid, triangular pyramid back here. So that again is another 6 by 11. And then divide that by 2, you get 33 feet squared. And then we look at this triangular face here, which is 8 by 11. 8 times 11 is 88. Divide that by 2, we get 44. And then we take its partner on the other side, the other face, 8 times 11, and divide that by 2, and we get 44. And then we can take 44 and 44 and 33 and 33 and 48, add those all up and get 202 feet squared. All right, one final example will involve a triangular pyramid. In this case, I've got one length of 7 and then another length of 8 with a slant height of 10. So I look at this face and I take my slant height of 10 and my base of 7, multiply those together and get 70, divide by 2 and get 35 meters squared. Now this face has a partner on the opposite side, okay? Because this dotted line back there is also measuring 7 meters. So that would be 10 times 7, again divided by 2, and get 35 meters squared. Then I can look at this triangular face here. Okay, so this is an 8 by 10. So 8 times 10 is 80, divide that by 2 is 40. And then I have the face that the triangular pyramid is resting on. Okay, the dotted line here. Okay, that one there, that's also an 8 by 10. So multiply 8 times 10, divide that by 2, and get 40 meters squared. And then I can take 35 and 35 and 40 and 40, add those together, and get 150 meters squared. Well, that is it for triangular and rectangular pyramids. We're going to be certainly doing some of these in class, and we'll see you then. Os!